Regeneration is an organism's ability to restore a damaged or missing part of its body. While this is often used to explain the longevity of superheroes and works of fiction, the reality is that humans do not have an extensive ability to regenerate parts of their body. The ability for large-scale regeneration is limited to a select amount of organisms. Humans, rabbits, dogs, cats, and mammals in general are pretty complex organisms. And since they're so complex, they're less capable of regeneration than more simple organisms, such as newts or sea stars. Sea stars especially have amazing regenerative capabilities. In the event that it loses a ray from a predator or by some other misfortune, the ray will slowly grow back. Here is a ray of an Amphira filiformis, also known as a brittle star, that is undergoing regeneration. We can see the original part of the ray here, and the new regenerating ray stemming off the original. Here is the point of breakage. After the brittle star had been damaged, the epidermis would have covered the damaged area, creating what is called the apical epidermal cap. Underneath the apical epidermal cap, adult cells will dedifferentiate into a stem cell-like state and form a blastema. HOX-A and HOX-D genes will activate at this site. Muscle and blood vessels grow within the apical epidermal cap from the blastema and reattach themselves to their original counterparts. This all happens in the same way that it had happened in the embryo. A fully functional limb will appear in about 1 to 3 months. What can we learn by studying these organisms? Well, as you know, there is much research being done regarding human stem cells in hopes that it will give us a greater ability to regenerate than we presently have, though probably not as extensive that organisms such as the sea stars have. Just as regeneration in the sea star begins from a mass of dedifferentiated cells, the use of stem cells in the right environment can foster regrowth and regeneration of damaged organs and systems. Sometime in the future, stem cells will be a viable regenerative treatment, but as of now we cannot quite take advantage of their regenerative properties. But we can take comfort in knowing that our own bodies have an innate ability to regenerate and do so extremely well. In extreme cases, a person's liver may suffer from diseases such as hepatitis C, tumors, or alcoholism. When this occurs, the patient's whole liver may have to be removed. In such an event, the patient will undergo a living donor transplantation. In a living donor transplantation, about 60% of a live donor's liver is taken and transplanted into the recipient. If all goes well, the donor and recipient's liver will regenerate to its original 100% capacity. Much of the human body is incapable of large-scale regeneration, but hopefully this will change in the future as research and technology further develop.